Welcome to Code Club. Please welcome my guests, regulars Dave and Tiago. Thanks for joining. Nice to have you. So, today we are going to look at a little project called GoScore. And what this is about appears to be scoring web pages or websites for security. What does that mean? Well, we'll find out. And it'd be interesting to see how they do it. So, quick look at the README. I'll link to the GitHub repo in the description, but quick look at this is when you search knowledge, suddenly you may see an alert by security scan tool. You have unfortunately displayed a site that contains a malware script, but you've searched a lot of for learn. I don't blame you. Can't we at least easily check if it's suspicious before we open it? I created this tool with that in mind for you. So I think that gives us a fair overview, doesn't it? It's sort of your own security scan tool. If someone sends you a random URL, you're not feeling too good about clicking on it, you can use this tool to at least get some information. So let's see what they do. Let's have a look at the code. So we can see this is a quick sort of helicopter view. The shape of the package is we don't have any folders. It looks like we don't have a bunch of different packages. We just have one Go file. That's great. It's all in package main. Maybe not so great, but you always need package main, don't you? If you want some tool you can run. You may have other packages, but maybe not. So we'll see. And it's MIT licensed. No tests, that's right. Or at least not that we've seen yet. It's MIT licensed, which is very important. It's important to have some open source license, isn't it? Or we wouldn't be able to use this library. Actually, we can't use this library anyway. We can't use it as a library because it's in package main, so we can't import that. Useful thing to bear in mind, isn't it? If you want anybody to be able to reuse what you've done, that bit needs to not be in package main. So let's start with imports. I always think this is what I look at first. It's like they say, women look at men's shoes, don't they, when they on a first date. This is sort of my first date thing as I look at imports, and it's always interesting when I work with people who are using Golang as their editor. It hides all your imports by default. It just collapses them up into import ... And of course you can expand them, but in general people don't. And I think this is probably not, what should we say? I think it would be better to show all the imports by default and let you use a setting to hide them if you want to, but I think they're worth looking at, aren't they? You can often tell a lot by what's imported. Standard library imports. Of course, we expect to see flag and font and OS. What else do we have here? We have an ini package, maybe something to do with ini files, we could guess. What about this? Rocket Launcher Google Search. That sounds interesting. I think search rank is one of the things that this tool looks at. So just to check the README again, I think, it's the main things is does the name resolve on the secure DNS server? Not sure what that is. Is the SSL certificate is not free type? So I guess we'll find out what that means, but I'm guessing they're looking for example, well-known CAs like Global Sign. Maybe Let's Encrypt is considered less secure. Not sure why. It's cheaper, that's for sure. And is higher rank search results on search engines. That doesn't, to me, have a whole lot to do with security, but nonetheless, it'd be interesting to find out how they do it. Termbox Go, anyone seen this before? I haven't.
Yeah, it's a cross-platform terminal UI.
Right. Sounds good. We'll see what that looks like.
Like cursors.
Right, and lots of standard library. So this looks pretty good. What should we do? Should we start with main and sort of that'll presumably refer to some of these types, and variables. Oh, well, there's an init, so let's start with that, shall we? That's where Go will start. So if you didn't know this, fun fact, you could be excused for not knowing it. If there is a function called init, which takes no arguments and returns no results, then that will be executed automatically when your package is first loaded, or all of the packages that you import in your program. When you run your binary that you create with package main, all of the init functions from all of the packages you depend on and all of their transitive dependencies will all be executed in some, I think, indeterminate order. There's no way to control that order. We don't tend to see this so much anymore. I think people have grown a little bit tired of magical behaviors like init, because you might look at this and just think, well, when is this called? I don't see a call to it from main. So when is it called? The answer is you just have to know that it's magically called.
What's the difference, right, of putting these two lines in the main?
Well, I think you've hit upon a really important point there, and that's, I think, the chief argument against using init is that we basically don't need it. You can just do it from main, can't you? Even in a package where you don't have a main function, suppose you need to do some prep, get the package ready to operate, compute a lookup table or something. You can do it with a var statement. So you can declare var lookup table equals call to some function which initializes the table, which effectively does the job of an init function, except it's not magic, isn't it? It's just plain old Go. So I think that's preferable. I always advise people not to use init unless they have a jolly good reason for it, which I haven't thought of, and nobody's come up with one yet. But what does this do? We call rand.seed, so this is the standard library math rand. We call rand.seed and we pass it something. What do we pass? We call time.now and we get some value, and then we call Unix nano on that, and it's the result of that Unix nano that we pass to rand.seed. Anyone like to take a stab at what's going on here? Quite a lot's happened, hasn't it, just in one line? So what do we think this is about? Something to do with randomness, we might guess.
Yeah, it's seeding the value for generate randomic numbers. Because by default the seed in Go is 1, so it's always going to generate the same token in the next line. So to avoid that behavior, you just pass a Unix nano, which it's going to be unique for each execution.
What does that mean, the seed, exactly?
It's the number used to generate the randomic, so it's the way to make a determinist function. A non-determinist no, it's the opposite.
Yeah, I know what you mean. I think we get the idea, and you might remember a previous code club where we talked about randomness and exactly what that means in general and what it means in Go in different ways to get randomness, and you can reference that video for more. But suffice it to say, as Tiago said, that the random number generator in Go is not random. If it were random, we wouldn't need to seed it with anything. It would just pick random numbers. But what it does is it takes some number and it sort of evolves it in a way that is in fact deterministic, that is to say predictable, but it looks random. If you didn't know the algorithm, it would look to you like just a bunch of random numbers. But it has to start somewhere, and it starts with 1. What does that mean? It means if you ask for, say, 3 random numbers in your program, they will always be the same 3 numbers. That sounds a bit non-random, doesn't it? But I mean, they look like a random sequence, but it will always be the same sequence unless you seed the random generator with some value. What value would make sense? Well, of course, if you always seed it with the same value, you'll always get the same sequence. So we want it to be a different number every time. What's an easy way to get a different number every time you run your program? Well, the current time is not bad, is it? That's exactly what time.now gives us. What does it give us? A time.Time, which is just Go's internal format for representing a moment. And we call Unix Nano on it because what we need is an int64 value, not a time.Time. And this is a great way to just quickly get, time.now is in fact some int64 number of nanoseconds since the epoch time, whenever it is, 1970. And Unix Nano just gives us that directly as a number. So that's okay. There's an interesting wrinkle with this in that, this gives us the time with nanosecond resolution, but your computer's clock does not necessarily have that degree of resolution. I'm not sure if this is the case anymore, but I think it used to be the case on Linux at least, that if you call time.now, you get the same value for about a second until the next second ticks over, and then you start getting the next value. So, if you run your program 100 times a second and you do this random seeding, you would always be seeding with the same value. Don't know if that's the case in other operating systems. Dave, do you know what FreeBSD does? Does it have nanosecond resolution?
Pretty much everyone moved to nanosecond resolution when they had to plan ahead for the 2038 clock rollover, which requires 64-bit time, and I think pretty much any operating system used today has dealt with that already, given that they've had 20 years since the previous year 2000 bug to sort that out. So I don't think you can get non-nano time anywhere now.
Yeah, that's a good point. Yeah, start your Y2038 preparations now.
Yeah, pretty much.
Don't leave it too late. Fine. So I think that covers that one pretty well. So we're going to be doing something randomly. What? We don't know. Perhaps we'll find out. Here's something. So we have some variable token which already exists, must be at package level. And we call some function rand.stir, and we pass it 8. Don't know what that means, but what could we guess?
I'm guessing some sort of unique identifier or semi-unique identifier that we use later on to talk to various systems. Probably a string of 8 characters, 8 runes, 8 bytes.
Yeah, that sounds like a reasonable length for a token, doesn't it? And it's a string, so let's just take a look at rand.stir. Okay. So Dave, why don't you read us through this one? And we'll see what we can work out. Just say what you see.
We've got a function that takes an integer, just an integer, not an unsigned one, and returns a string. Then we make, what is that? An array of runes.
A slice of rune, yeah. There'll be some underlying array, but we normally just refer to it as a slice.
Why do we need to make it? That seems odd. A length n, and what do we do? We make a loop over the size of the rune, which in theory would be, the size of the slice of runes, which in theory would be length n. I don't know why we can't use n again.
So we're ranging over that slice that we just created, which is n elements long, isn't it?
Yeah. Starting at 0 and going to n minus 1. So in 409 we start off and initialize each element of our slice to something. What have we got here? Starting off in the end, RS1 letters, which is not defined.
Yeah, so it's work from the middle outwards. That's a good idea with things like this, isn't it? So there's something RS1 letters. What's that? That's some slice of rune. Let's just check this because it must be one of these things.
Up the top, some sort of package.
Yeah, here it is.
There we go.
So that's all the
So the
letters.
standard alpha, lowercase and uppercase alpha characters.
Okay. Now what do we do with those?
And then we take the length of that, and then a rand int n, and I have a vague recollection that this returns you a random number in an interval given by, if you only have one parameter, from 0 to len minus 1. So why don't we look at rand.int n and see what the definition of that is. Returns as an int, a non-negative pseudo-random number in 0 to n from the default source. So there we go. So we take the length of the slice of runes RS1 letters, and then we pluck a random number within that range, 0 to n minus 1 inclusive, and then we use that as an index back into the slice of said array and assign that to the first, to the item of our range. So what we're really doing here is taking a random letter out of RS1 letters and dropping it in rune by rune into the slice we just made.
Right.
And finally return a string B.
Yeah, sounds reasonable. So now we know what at least part of that randomness was about. So, okay, so that's in it. So we seed the random generator. We compute some random 8 rune token. Don't know what that's for yet. Here comes main. So this is where it all starts. So Tiago, would you like to read a little bit? Just talk us through this part. What's happening here?
So we are running termbox.init and assigning the result to error variable.
Yeah, apparently that can error. Well, not sure how. We didn't pass anything to it, so there's nothing that could be invalid. Does it say? It actually doesn't.
I could understand you having an error if, logically, if there's no actual terminal. So if you double click an executable, then there won't be a terminal, for example, on Windows.
Yeah, that's a good point. That would be something they could explain in this comment, wouldn't it? I think that's a useful thing to document in your API. You know, if your API returns error, say how that could happen, because that's sort of important if you want to know what to do to handle it, isn't it? First thing you need to know, well, what kind of error could it be? You might run it a dozen times trying to get it to give you one, and it won't. You know, it's always nil, so you just think, oh, well, maybe it never errors. But then maybe it does. So what do we do then if that error's not nil?
It's not new, we panic the error. And then we defer the close function, termbox.close.
Right. So we're not. So it's interesting that we're not. Sometimes you call some constructor, you know, and it gives you the object, the termbox object or whatever, or a session object or a client object or something like that, and then that has a close method or a flush method or something. But that's not the case here, is it? You call some global init, and it just globally initializes it, and then you defer globally closing it and globally flushing it, I guess. Would that be a concurrency issue in parallel tests or in Go routines, for example? I mean, you know, if there's probably just one terminal attached, so maybe that's all right. But what about parallel tests? Could that blow up?
Probably. Not sure without reading the code, but probably.
Yeah, I would just automatically assume that will blow up. I'll just say perhaps maybe they've provided some way around this where you can in fact construct some termbox object and use it in a concurrency safe way. But if you don't need to do that, they've provided you just simple wrapper functions which just implicitly do that for you, like the default HTTP client. We don't know. And we don't care for the purposes of this. Maybe look at that in a later code club, but yeah, something to do with talking to the terminal. So what's next?
So we are defining a set of flags like debug, certificate, key, port, and config. And then we parse all these flags, calling flag.Parse.
Yeah. And this is an interesting... It's funny how the same topics seem to come up in phases, you know. Like this week, for me, with students, it's been all about flags. So, you know, everybody's kind of trying to write programs that use flags and how to test their logic around flags and things and asking questions about it. So one thing that we found out this week is, you know, with the standard flag library, this is how you define flags that your program takes. Is you could say, for example, flag.bool, please define some Boolean flag which can be on or off. Here's its name, debug, so that you would specify -debug to the program to enable that flag. The default value, which in this case is false, and a help message so that if you run the program with no arguments, for example, or with -h, you might see all of these possible options printed out with their help messages. So you define these, you tell the flag library, hey, you know, prepare to receive this flag. Don't do anything yet, just be advised this flag may occur. Here's a string flag, for example, which can have some value, like the SSL search. And then we call flag.parse to say, actually parse the arguments that I got to this binary and see if any of those flags were among them, and if so, update these variables that I've associated with them. So flag.bool returns a pointer to bool. Why a pointer? Because it's going to update it later in flag.parse. So these tend to be pointers. And what does flag.parse, what does it parse, you might ask? The answer is os.Args. That makes sense to us, doesn't it? os.Args tells you what arguments you got. It's a slice of string where the first element is the path to your program's binary. This is classic Unix API, isn't it? And then element 1 is the first command line argument, if there was one. So it'll be, you know, a sort of a white space separated bunch of stuff, bunch of possible flags, flag values, command line arguments which are nothing to do with flags. So you have this os.Args slice, and if you call flag.parse, it parses them. So obvious question, how do you test that? Because suppose you have some logic around your flags, like if you specify this flag and it's a Friday and it's a full moon, then enter werewolf mode. You know, that's a behavior, so it's something that you can test. How would you test it? Well, you could execute. You could build and execute your binary from the test, pass it that flag, and check that it produces the right kind of output. But that's a lot of paperwork to do, and it's also quite fragile. You know, you don't really want to be in the business of parsing your own program's output to try and work out if it did the right thing. You'd prefer to do this at the Go level, wouldn't you? You'd like to call some function and check that you get the right result. So how could you do that? Well, one answer might be to just set os.Args to something and then call flag.parse and say, hey, what was the end result? That doesn't feel like a great idea, does it? We don't in general want to have any global variables, and if we do have them, we definitely shouldn't vary them in any way, because then that wouldn't be concurrency safe. So imagine, you know, 50 parallel tests all testing 50 different test behaviors, different flag behaviors. They're all trying to set os.Args to different things concurrently. That sounds like a recipe for trouble. So we wouldn't want to do that. So how can you use the flag library to parse something that's not os.Args? You know, what would you do? You could make your main function just a thin wrapper around some function called run, let's say, which just takes a slice of string, and then main can call it and pass it os.Args. Now you can call run from a test, can't you? And you can pass it any slice of string you want. But how do you tell flag to pass it? The answer is there's a thing called a flag set, which doesn't really matter what that is. It isn't anything, but if you call flag.NewFlagSet, it will give you this object, which is, essentially representing something that can parse and set a bunch of flag values. But the flag set object has a parse method, and it takes a slice of string. So that's a long and rambling answer to my own question, which is sort of, that's how you could test flag logic, is you could call new flag set, then it's a case of calling bool method, string method, whatever, to define a bunch of flags, and then call parse and pass it your test command line, for example. So now we know that this flag.bool is really just a method on the default flag set, isn't it, in effect? And flag.parse just parses the default flag set with os.Args. So it's more than you wanted to know, I'm sure. So we have that. So we have parsed our flags. So we now have them or don't. We have this variable debug, which is global. It's a bool. Sounds like it enables some kind of debug mode, doesn't it? This is pretty common. What do we set it to? We look at the variable that we associated with the debug flag was called _debug, and it's a pointer. So what we do is we dereference that pointer, we convert it to a bool, we convert the result to a bool, and we assign it to debug. Some of that is probably unnecessary. If you have a pointer to bool and you dereference it, what do you get? Pop quiz. Anyone know?
You get a bool, sure.
You get a bool, that's right. So why would you want to explicitly type convert a bool to a bool? You wouldn't. So I think that's probably just unnecessary.
Just a comment on parsing flags.
Yeah.
When you go and look at flag.parse in the standard lib, it's actually a very short one-line function that says command line.parse os.Args.
Right.
Rest of the slice. And then after all of that, it's all flag sets, which means you could easily test it. Exactly.
Yeah, that's exactly what we said, isn't it? So,
yeah.
So they do, in fact, it's all set up to be concurrency safe, but they don't make you do the paperwork if you don't need it, which is great. And I think that's, I always try and copy that similar sort of API. So I make it possible to have some object which is customizable and concurrency safe, and you can have one per go routine. But if you just need one of them in your entire program, no need to go through all that paperwork. So that's great. And I think, should we say a word about, random Go libraries in general? Like, I think a lot of people quite reasonably feel if they are beginners in Go themselves and looking at stuff on GitHub, browsing random repos, this is a fun thing to do and worthwhile. But how can you know if what you're looking at is any good? We could phrase it that way, couldn't we? In other words, if you see something, you might think, okay, should I do that? Is that the way we do this? Is that a good idea? You don't know. You don't have the background yet to be able to evaluate that, and that's fine. That comes with reading more, doesn't it? And trying stuff out yourself and saying, hey, I tried that thing from that random library and it really didn't work. It was horrible. Or it might be a great idea. We don't know. So I think, some people look at the standard library, for example, which is a terrific idea, and we've done that several times in Code Club, not for the last time. But again, should you emulate what you see there? Maybe not. I mean, there may be perfectly fine bits of Go code in there. I'm not saying the standard library is bad. It's just very specialized. You know, all sorts of weird and unusual constraints apply to the standard library, which don't apply to regular Go packages. It's the standard library. You know, that's an unusual thing to be for a Go library. And, you know, in many cases, as Go has evolved, or not Go, but the way we use Go, you know, the conventions, and people have had good ideas over the years about how to do things. And the standard library hasn't really been able to change to catch up because it's sort of fixed. You know, it needs to keep the same API at least. So that's one thing maybe not to take as your model. Another thing might be really big and complex projects, isn't it? So, for example, you know, one corporate team that I'm training at the moment, they wanted to look at some non-trivial Go program, so they suggested Kubernetes. I mean, that's non-trivial, absolutely. Maybe it's not quite trivial enough to be, you know, there are lots of interesting, Kubernetes project is so vast, and it's also, again, extremely specialized. It doesn't provide lots of examples of the sort of things that we would probably need to do in regular Go programs, does it? It's primarily about being a super high performance API and things like that. And it's also absurdly complicated, so you probably expend a lot of brain power just figuring out, you know, what is all this stuff? Never mind, how does it work? And you sometimes just, some libraries just have randomly weird things in them because that's the way the maintainers like to write them. Like we were looking at GoKit the other day, which is quite an interesting library. And if you haven't come across it, it's sort of a framework for writing microservices in Go. And they have this weird thing where they write unnecessary blocks. You know, they'll write a curly brace to open a block here and then stuff inside the block. And you're just like, but what's this block? It's not doing anything. Except potentially shadowing variables. And, you know, I've seen some people sort of copying that, thinking, well, I saw it in a well-known Go library. You know, this must be a thing, right? Spoiler alert, it's not. Nobody does that, basically. Just doesn't mean anything. So, but I can see where people might just start doing that because they saw it in this library, and then other people see them doing that and think, oh, apparently that's what you do. You just create blocks for no reason. So watch out for that. What are we really saying is we're probably saying something like, it's not a great idea to just pick some project on GitHub and take it as your single source of truth for everything to do with Go. You know, it's tempting, isn't it? Anytime you have a problem or not sure what to do, just think, what does GoKit do? Let's do the same as them. That's maybe, not to say that it isn't helpful to look at these things and to take the best ideas from them, but blindly using stuff as a model without any understanding of whether that's correct or common or desirable, probably a mistake, isn't it? So, rant mode cancel. That's, you know, just my thoughts on that. Let's move on then. So we've set our debug flag. We call some load config function. What do we pass it? We take our _config variable, which we set from a flag. That was a string flag saying config file name equals such and such. We dereference that pointer. We turn it into a string, again unnecessarily, I think, and we pass it to load config. What does load config do? That sounds fun, doesn't it? Let's take a look. Let's see, let's have another reader. Perhaps, Sharif, would you oblige us with a little reading here? You can read this kind. Yep.
File name string. First we're trying to clear load option with an I. Load option.
Yeah, there's this ini package which we imported, wasn't there? So that has some load options struct type.
Yeah, it's right. Yeah.
Don't know what that's about, but we can guess it's something to do with loading options from some file. What next?
I'm trying to read this unparse able sections equal slide string.
Yep.
We try to make a slide string for cache images history.
Okay. So these sound like they could be sections in the config file, don't they?
Yeah.
What next?
We have config error. We declare it. Yeah, the load option and file name.
So we call some load sources function in the ini package. What do we pass it? We pass it the load options, so just to recap, so we created this load options thing. We set its unparsable sections field to a slice of strings, cache, DNS, etc. Not sure why we need to do that or why they're unparsable, but I guess we're just telling it these sections exist. And then we're saying, given some file name representing an ini file, please load that. Here are the options, and here's the file name to load from. That gives us back two things. What does it give us? It gives us CFG, which is a pointer to an ini.file. Don't know what that is, but we can guess. And some error. So, yeah, at least we know what the error is, don't we? That's familiar. So what do we do with the error? What do we usually do with errors? It's pretty standardized, this, isn't it? Check if it's nil or not. And if it's not, what do we do?
We handle the error, like whether we want to not print it or return it or...
Yeah, and we do something. Not sure whether we can describe it as handling the error. What we do is we print to, I guess, just standard out, fail to read file %v, and we give the error. And then we call os.Exit 1, so exit with error status.
Probably this could have been written in one line with a title or something, right?
So we could imagine that's maybe, file doesn't exist, or you don't have read permission, or someone unplugged the disk halfway through reading it, something like that. What do we think about this error handling? Any comments?
It would be a surprise to call the function and have it quit on you. You normally expect to do that in main. So yeah, we should return a wrappable error and then let the calling function decide what it wants to do.
Yeah, I sort of think printing to the terminal may be of no use. But there may not be a terminal quite often with Go programs. Think about a web server, for example. No good printing to standard out. No one's going to see it unless they just enjoy reading log files, which I know some sysadmins do. So that may, if we really want to log something, we should log it, shouldn't we? Rather than just kind of printing to the output. Our log destination may in fact be standard out, but we don't know that. More likely to be some log server. And we exit, which, as Dave said, I just think that's a little rude. It's not for us to call os.Exit here. We're in some function called by main. It may be that whatever the error is, the person that called us will decide, actually, no, that's fine. We can carry on. Doesn't matter if you can't read the config file. If you had referred the decision to me, I might have decided not to terminate the program, but too late. you know. It's sort of breaking the commandment about restricting user choice, isn't it? I sort of think it's like if you lend your car to someone for the weekend, you know, and then you expect to get it back on Monday, but they said, oh yeah, I found the cigarette lighter wasn't working in your car, so I just had it crushed. You know, I assume you wouldn't want that car anymore because it was defective. And because I'm like, no, actually I could have lived without that. I don't smoke. So the car would have been fine. You know, you should have referred that decision to me. It wasn't yours to make. So you wouldn't do that with your friend's car, and you should also not exit their programs, I think. So what would the right answer be? I think, Vignesh, you were saying you should just return this error, shouldn't you?
Yeah, that's what I think. I mean, you can return the error and let the calling function decide what they want to do here. Yep.
Yeah. So we would have changed the function signature of load config to say, actually, this can error. That's what that means, isn't it? If you return an error, you're saying something can occur which is erroneous. If you don't, then you're saying this will never return an error on you. I mean, it can't. So either this always works, or if it doesn't work, we'll just crash. And that's very much less desirable. But you have no way of knowing. When you do that, you know, if you're saying, I am going to succeed in this or crash, either way, we won't be returning anything. The convention is to name your function must such and such. You know, like a regular expression must compile, because if it doesn't, then it panics. I don't recommend you do that. You know, you should never panic, and you definitely shouldn't panic or otherwise exit the program outside of the main function. But if you do, you should name your function must so and so in order to signal to the reader that that's how it works. So fine, that's and we know with any function called something like load config, takes the file name. Can that error? Of course it can. Anything to do with files is, you know, just a minefield, isn't it? So we expect that. So here's some stuff we do. Having successfully loaded that config, we call some set cache function, and we pass it. We have some score variable. Where does this come from? It must be global. So let's go find it. Score is a variable of type score data. What is that? It's some struct. It has a cache field, which is int64, a pcache, which is a string, DNS is a slice of string, search is an int, and SSL is a slice of string. This sort of looks like it's going, since this program is about scoring websites on various categories, this looks like where that score ends up, doesn't it? We're going to compute some value of this struct somehow. We haven't got there yet, and we might well not get there, but let's try. And there's a lot here, really, isn't there? So just increase speed slightly. I think so. We're setting up. Presumably, this config file can configure something about how these things are scored, and that's what we're doing. So let's go back. So we're back in main. So we've loaded our config and crashed, or not. If not, we're still here. And then we use the go statement to start some go routine. So this is always fun. As Tiago knows, you know, it's easy to start go routines, not necessarily so easy to know when they're going to end, or how they end, or how to wait for them. Always something to bear in mind. But we're doing something concurrently, aren't we? So some func in this case. So what do? So we call http handle func to say, please register a handler for this endpoint, which is /token, and the handler is start handler. So we can look at that in a moment. But we also, this is a truly joyous block of code, isn't it? So we have We call http handle func again to say please handle this endpoint that I'm going to give you, which is slash plus the value of token, which we computed earlier, plus slash API. So now we know what that token's about partially, don't we? We constructed this 8-character random string, and we're saying if you call us, we're going to start some HTTP server, and if you call it with this URL containing the token, we will do something. It's kind of an admin interface, I guess, isn't it? It's, you know, if you have some privileged HTTP function like blow up the world, you want to secure that somehow. And the way they do it here is by, you have to supply this token. I guess, how would you know the token? The only way you know the token is if the program prints it out, perhaps, to say, you know, you must be the administrator because you ran me, so I can give you the secret token. Please use this when you call me. So what handler do we associate with that endpoint? Well, it's this function literal, which, like all HTTP handlers, takes an HTTP response writer to write something back to the person who requested this, and it takes the pointer to the HTTP request as well, so we know what it was. Here's the handler. So what do? We call, let's work from the middle out. We have the HTTP request as R, that's conventional, and it has a field called URL. So the request tells you, you know, what was the HTTP method, what was the URL, what was the protocol, a bunch of other stuff we don't care about. We're interested in the URL here. What was the path? That would be like slash token or, you know, slash API, whatever. When your handler is invoked, you'll get the request and it will tell you what URL got you here, sort of thing. That makes sense, doesn't it? So we're going to get that path, and then we're going to call strings.lastIndex, and we'll pass it the path, and we'll ask for slash. So I think this is saying, given a string and some substring, where is the last place that this substring occurs in the string? So in this case, we're asking, you know, what is the index position of the last occurrence of slash in the URL? Yeah, that looks right. Or -1 if it's not present. So, fine. What do we do with that? Well, we use it to index our.url.path. So, we're essentially saying get the last slash in the path, aren't we? And then add to it, get the index to the last slash, add 1 to it, and then take a slice of the path from that point to the end. So that was a lot, and we're still inside some brackets, so we're not done yet, but let's just recap what we figured out there. So we have some URL of the request that we're handling. We get everything after the last slash. It's a good way to say it, isn't it? And then we pass that to base64 URL encoding decode string. So if you have some string which happens to base64 encode some data, this will give you the data. Base64 is, if you don't know, is essentially a way of representing arbitrary binary bytes as printable characters, isn't it? So something you can copy, print out to the terminal, paste into emails, and I think it is used in email, isn't it, to encode binary attachments. It's not encryption. It makes things proof against the non-technical. You know, anyone who doesn't know what base64 is, this would be effective encryption against them, but not otherwise. So what are we saying? It looks like we're saying you could be called with some URL which starts with the token, and then we have /API, and then you have some base64 data. We're going to decode that So we're going to get a slice of byte representing the data encoded in that string, and some error because we might not successfully decode it, but let's assume we have. And we're going to assign that to a variable called server name. So all of that complicated business was basically saying, the last component of this URL path is a base64 encoded server name, isn't it? Does that make sense to everybody? Maybe we could have expressed this perhaps more clearly, couldn't we? But this sounds like a reasonable interpretation. So what then? Well, there could be some error or not. So if error equals nil, which is a bit unusual, we're used to seeing if error not equals nil. So we tend to interpret, any block that looks like this as saying this is the error handling, but in fact it's not. It's saying if there's no error, then do this. If there is an error, then I guess do nothing. So I think that's what I'd write. Don't you? I think I'd say if error not equals nil, return. Or maybe more.
It might even be nicer to wrap all of that up into its own little function so that the go func bit is nice and clear, and you go, yep, token, start handler, handle func, all good, and then pass in debug true as a flag to it, and then you would read it and you go, oh yeah, there's a debug flag there, cool, I can look at the function if I need to know exactly how it does it, but I'm not disturbed reading the flow.
Yeah, that's exactly what I would do too. This just feels like way too low level for the level of abstraction we want to be in, doesn't it? When we're looking at an HTTP handler, we want to basically see something like unpack your arguments, do the business logic, format the response. Ideally, it would actually just be those 3 lines. Then, all 3 of those functions are trivially unit testable. We don't need to make HTTP calls to test them. And we can see by looking at the three-line handler that it's correct, so we don't even need to test it, maybe.
And I'm not sure why he needs the server name if the listening serve DLS function is not passing any server name, it's listening to everything.
Yeah, I assume, I'm going to guess, without skipping ahead, I'm going to guess that the server name we're receiving here is saying, please scan this website, if you like. Isn't it like
because of the SSL, right?
Yeah, I think
the server name for the SSL.
We're starting some web server here. What are we going to do with it? We're going to call it to say, please do a security scan on bitfieldconsulting.com, for example. Other websites are available, but not as good. So there could, as Dave said, this feels like something where you would say, extract server name from URL brackets r.url, isn't it? And that either works or it doesn't. If it doesn't, that means someone tried to pass us a base64 encoded server name, but they messed up somehow. There was a decoding error. So I feel like we should tell them about that. Perhaps return some HTTP status, something like 400 or 400 something might be appropriate, mightn't it? But fine. This is another example of what we were talking about earlier, isn't it? That you can look at libraries and say, well, I don't think this is right, I don't think they should do it this way. That's no criticism of the person who's written it. They probably think the same themselves now. When I look at stuff I wrote last week, I think, what was I thinking? I know a much better way to do this now. That's great. It means I learned something. It would be worrying if that weren't the case. So that's fine. So I think we should treat all our code like this, whether it's something we've written or someone else, just treat it as this was written in good faith with the best knowledge that the person had at the time. They've probably evolved slightly since then and would maybe, do it better. That's great. So if there is no error decoding that server, then we have the server name. So what next? So if debug equals true, and I think the linter is going to suggest a refactoring, it says const true untyped bool equals true. That's fine. That's a pre-declared constant in Go, should
You can
omit.
remove the equal true. That's what it's saying, because if
Yeah.
debug's the same as equal true.
Exactly. Should omit comparison to bool constant can be simplified to debug. So it's sort of saying if x equals true, it's just a long way of saying if x, isn't it? Because the argument to if is some Boolean expression, like x equals true, but what is x? It's a Boolean variable which can be true. So if it's true, of course it's true. And this is a nice... by the way, this is from static check, so it's been quite interesting to see. I think in the most recent release of the VS Code Go extension, they switched to defaulting to static check as the linter instead of golint. This is interesting and I think great. Static check is excellent. There's a ton of Go linters, or things that call themselves linters or static checkers, you know, things which can look at your Go code and complain about it. Most of them I think are probably not worth bothering with. But some are. Static check is very good. Golint is very good. One thing, so static check has a ton of these kind of rules which just says this is a well-known thing which is probably wrong, so I'm going to warn you about it. You probably don't need to do this. It's not infallible, but it's pretty good. I think you can configure disable certain rules if you want to. One thing static check doesn't do, which golint does, is it doesn't complain about missing documentation comments on exported identifiers. We don't have any here because there's no package, so there's nothing to export. But for example, you know, if you have a package and you have some exported function in it, if you put a comment right before that function and the comment starts with the name of the function, then the Go doc tools will recognize that automatically and they will produce nice HTML documentation which will appear on package.go.dev. And that's very nice. And it will also appear as a hover tip in your IDE. So, you know, if there were a comment on the debug variable, we would see it now when we hover over debug and it would explain what it's about, which is great, isn't it? So if we hover over url.path, we see this comment, path, relative paths may omit leading slash. That's helpful. So the standard library does this. We should too, shouldn't we? So I think it's a shame that static check doesn't complain about that. But in one sense, I can sort of understand it, because if the first time you ever get that warning, you'll be like, oh, I should write documentation comments. Okay, I'll do that. You know, or you might say, I don't care about documentation. I don't want anyone else using my code. It's mine. I want people to be puzzled and helpless when they try to steal my Go library. So that's fine, you know, that's defensible. But after that point, you won't need reminding, will you? It's not sort of easy mistake to make, missing them out. You've either decided that you're not going to write documentation, or you've decided that you are. Either way, you don't need the lint check. So I think I understand that. So that is a good refactoring, and Golang does similar things, by the way, I should point out. So if debug is enabled, what do? Print something, again, to stand it out. So we better hope there is one. We print API call, and we give it the request.remote adder. So this is the address that the request came from, if known. Not always known, or it may just be something irrelevant like a proxy. And the server name. So we essentially say, you know, such and such an IP address called us with this server name, and we log it, sort of thing. Not really logging, but printing. And then we call some function API handler, and we give it our own response writer, our request, and the server name. So that presumably is the bit that actually does anything, API handler. So the rest of this is just, we call http.listen and serve TLS to say please be a TLS server on a certain address, which is set by our flags, and that can error, but not until it shuts down. So the API of listen and serve anything is just keep listening and serving and don't ever return until you're done, usually because some error occurred, like maybe you got a kill signal. And we then log it. We call log.fatal here, which has the effect of printing to standard error and exiting the program. That's okay. And then, having started that go routine, which starts the web server with its handlers, we then print out press enter or space key, server status display, escape is exit. We call some function start server, and we give it the port value that we set via flags. And then we save config. We give it the config file name that we set via flags. So fine, so we're almost out of time, but I think we can look at API Handler, can't we? Because we'd like to see it do something. This is going to score the website, we assume. So we set some headers. These are probably important, but most likely not, including content type is JSON, so that's useful to know. We call some function check history, and we pass it the server name. And it returns something which we assign to the variable scores, which is just a string apparently. So we then do some stuff with scores, which I guess this is about formatting those results, isn't it, to eventually return some JSON. Fine, so what's check history then? We get the time now, we assign it to t, and then we have a loop from 0 up to the length of history. What's that? Some global variable again. It's a slice of some type called history data. What's that? It's some struct with a URL which is a string, time which is an int64, and a score which is a string. So we can guess this is something to do with scoring websites, can't we? And what do we do in this loop? We say if the server name is equal to the element of history that we're looking at, URL field, in other words, it looks like we're looking for a record in history which matches the server name we've been asked for. If we found it, then what? Well, if t.unix, so this was the time.now at the start of this function, so we get it in Unix format, which gives us an int64, same as Unix Nano, except not nano, just 1 second resolution, right? So in other words, if the time.now is less than the time field recorded in history for this server, then return the score field of this history element. So what is this doing? I think something like this is a cache of sites which we've already scanned, in effect, isn't it? Saying I don't need to do all of my checks again for this site because I already did it at some point. But this is slightly puzzling to me because it says if the time now is less than the time recorded, you'd think it would be greater than, wouldn't you? Why is it less than? Or is this time field, is that sort of the last time that this history record will be valid? Anyone got any ideas? We're struggling a bit, aren't we?
I wonder, like, why do we even need time, right? I mean, can't you just say that, if the server is already in the history, just, provide data, right? Or I mean, at least it got to be, time is greater than the historical time, not like less than the historical time.
Yeah,
the current time can't be less than the historical time. When will the code will ever come here?
Yeah, I feel the same. So this is the sort of thing where if I were writing this, it's really difficult to both sort of design an elegant function and worry about readability and figure out how to express the logic that you want in Go all at the same time, isn't it? Stick to doing just one thing. Just try and write a working function in Go, and then once you have it, your tests will tell you when it's working. And once you've done that, say, now let's take a look at this with my Code Club classes on. Is this readable? Would Dave, Tiago, Sharif, Vignesh and friends figure out what this is about, or would they be a bit puzzled? If so, I don't want to be embarrassed. When they look at my project on YouTube, I'll maybe put a comment in to explain what this is about. And then if you're really bright, or you studied at BIT or something, you might think, hey, why don't I just forget about that comment and just rewrite the code so that it's so clear it doesn't need an explanatory comment anymore. That's a somewhat higher level thing, isn't it? Not everybody is capable of writing code like that. Some of us have to resort to comments. That's okay. As long as we know that we're on a journey, and our destination is a place where our code is so obvious we don't need comments. That won't be controversial, I'm sure. But, it's not... My friend Matt Ryer always likes to talk about glanceability in relation to code, and I think that's a great word for it. I think the glanceability of this could be improved, because I glanced at it and I sure as heck didn't understand it. I don't think we should be doing this kind of time math in any case. And if we were, this isn't the way to do it, because time values, suppose you had some time.Time value representing a particular moment and you wanted to say, is that now? If I call time.now, is that equal to that time.Time that I have? But that could be a tricky process, because there can be jitter in clocks, and the value can be inexact, and time doesn't always go forwards. This is a well-known fact to anybody who knows about things like leap seconds. And seconds don't always last a second. If you're on Google Cloud, your time is smeared out for the 24 hours preceding a leap second, so that it's just 24 hours and 1 second long. So there are all sorts of confusing things about time, so we shouldn't really treat them as numbers that we can add and subtract from each other. What we have is methods on a time.Time which we can use to do that. So a time.Time has a before method. Here it is. And we can say, is time X before time Y? Straightforward. We might have done that by subtracting, but we've had some reasons why that isn't a good idea. And also time.After. And equal. So, you might think, why not just compare if the two numbers are equal with equals equals? See the documentation on the time type for the pitfalls of using equals equals with time values. Most code should use the equal method on the time value instead. And I second that advice. I think it's good. So, little code review note there, isn't it? So, fine. Well, unfortunately, I think we've run out of time for today, although it has been fascinating. And there's more interesting stuff here, which we could have looked at, but don't worry, because we never do get to the end of things. That's all right. Leave that as an exercise for the viewer, isn't it? They can go and investigate this themselves and perhaps comment on the video to say interesting things they found about it. Well, thank you very much, ladies and gentlemen, and gophers of other genders, including indeterminate and neutral, and indeed nil. Thank you for joining me, and I will see you all next time.
Thanks. Have a good weekend.
Thank you.